All right, let's finish this paper. Left off at number 35, we're at number 36 now. The diagram shows a circuit consisting of a 6-volt battery, a 3-watt lamp, an ammeter, and a voltmeter, which shows the correct readings for the ammeter and the voltmeter. So we're asking about the current and the voltage. We know the voltage and we know the power. So we can use the relationship power is equal to current multiplied by voltage. Just make that a different color so you can see. Okay, we can use this relationship and we're going to transpose that to make the current the subject. So we're going to say current is equal to power divided by voltage. The power is 3 watts divided by 6. Power is 3 watts divided by 6 volts. And that will give us 0.5 amperes. So we look for the row that has 0.5 amperes, A and B, so C and D are out, and then the corresponding voltage is 6, so our correct answer is A. Right? Number 37. A householder uses a 2000 watt electric water heater on a timer. If the timer switches on at 6 a.m. and off at 10 a.m., what will be the cost of operating the heater each day if 1 kilowatt of electricity, 1 kilowatt hour of electricity costs 20 cents? All right, so in order to find the cost of electricity, we need to multiply the number of kilowatt hours by the price per unit. Okay? To calculate the cost, to calculate the number of kilowatt hours, what we're actually doing is calculating the energy. Recall that energy is equal to power multiplied by time. And in this case, the power must be in kilowatts and the time must be in hours. So here we have 2000 watts, that's equivalent to 2 kilowatts, and our time is given to us right here. We have a time period 6 a.m. to 10 a.m. 6 to 7, 7 to 8, 8 to 9, 9 to 10, that's a total of 4 hours. Okay, so our number of kilowatt hours is going to be our power in kilowatts multiplied by our time in hours. So I'm going to work that out on the side here. So number of kilowatt hours is equal to 2 kilowatts multiplied by 4 hours, which is going to give us 8 kilowatt hours. Remember, kilowatt hours is a unit of energy, okay? So if we use this much electrical energy, 8 kilowatt hours, and every one costs 20 cents, then how much do we owe BPL at the end of the month? 8 kilowatt hours multiplied by 20 cents per unit. So we owe $1.60 for the use of that electric water heater. That is not realistic, of course, but that's the answer, C. All right, number 38. In which circuit does the resistor R have a resistance of 12 ohms? So you might have looked at this question and it's like, okay, you didn't give me any other information. I don't know anything about the current, And I'm with you on that one. It can be a little off-putting. So we're going to make an assumption. We're going to assume that the current is 1 ampere. And we're going to use our Ohm's law relationship. And we recall that Ohm's law says that the voltage is related to the current and the resistance by this formula. Voltage is equal to current multiplied by resistance. And if we want to find the resistance, we're going to transpose that, and we're going to have the resistance equal to the voltage divided by the current. And if we say the current is 1, then the resistance is going to be, in order to get 12 as our resistance, we have to have 12 volt supply. So answer is going to be C. Number 39, this one is about magnetic fields for bar magnets. So I'm just going to write a couple of ground rules. So first we need to remember that the lines go from north to south. When they're attracting, the lines are joined, and when they're repelling, we have an empty space in the middle. Okay, so I'll give you a second to look at these and see if you can figure out which one is the right answer. Pause it. Got it? All right, so looking through them, we need to look for the direction and the shape, okay? So let's check out the shapes first so we can do some elimination. We know that if they're attracting, then the lines are supposed to be repelling. If they're attracting, the lines are supposed to join up, okay? It says repel and the lines are joining up, and we can confirm that we have 2 like poles, so they should repel. So that's not what we should be seeing, so that's out automatically. Okay, here we have attraction. We have 2 unlike poles, so that's correct. So that is a contender. We're going to leave it for right now. Let's check out the others. Let's look at C. Okay, we have repulsion, south pole and south pole. That's good, and we have our empty space, so the field shape is correct, so we're going to leave that for now. And what about here? We have north and south, and they're attracting, and the lines join up, so yes, that fits the criteria for the field shape. Now let's check out the direction. Okay, the lines are supposed to go from the North Pole to the South Pole. So the North Pole should have arrows that are leaving or going outwards, and the South Pole should have arrows that are coming in. So this one, we already exited that out. Let's look at B. Okay, so do we have lines going from north to south? No, they're going from south to north. So that one is out for that reason. C, lines should be coming, arrows that is, should be coming into the South Pole. Okay, they should not be leaving the South Pole. They leave the north and come into the south. So this one, the direction is not correct. And that means that our correct one is D. We see our lines have a direction. They're going from north to south. So the shape is correct and the direction is correct. So our answer is D. Yes, I know that might have seemed like a lot, but trust me, you want to go through it systematically. You have 2 things you need to look for. You need to look at the shape and the direction. And don't just take it for granted and look at the labels that say repel or attract. Make sure that they are actually like poles like poles repelling or unlike poles attracting. Okay, so check everything out. Make sure you got it right. That 1 point can be the difference between an A and a B. All right, next question, number 40. Which of the following materials is the best choice for the core of a transformer? Laminated iron, laminated steel, solid iron, or solid steel? Okay, we want to say no to steel because we want our transformers to be efficient. And if we use steel, we're going to have to use a lot more electrical energy, a higher voltage in order to magnetized steel, because steel is a hard magnetic material. So you want to go with a soft one. So that leaves us with solid iron or laminated iron. Well, we just talked about efficiency. We want our transformer to be efficient. We already have a lot of extra heat coming from those windings. So we want to laminate the core so that we can insulate it and prevent a lot of energy from heat loss. So A is the best choice, laminated iron for transformers. Number 41, I can open this a little bigger. Diagram shows an ideal transformer used to operate a 24-watt lamp from a 120-volt AC supply. The transformer has 1,000 turns on the primary coil and 100 turns on the secondary coil. What will be the power input to the transformer? Okay, now before you get lost in the numbers, I want you to look at what you're being asked, okay? Power. One of the principles of ideal transformers is that the power remains constant. So the power that goes in is the same power that you get out, okay? The ratio remains the same on both of the coils. So if the secondary coil has a power of 24 watts, then that means that our primary coil has the same. So B. All right, number 42. In which of the following would you find a commutator? Okay, well, that would be in our DC motor. Commutator, that's the same thing as a split ring. So full name, split ring commutator. That's the part of the DC motor that is responsible for allowing a continuous rotation because it switches the terminals every half turn, and that reverses the current, which reverses the forces on each side of the coil, allowing it to turn in the same direction. So DC motor is our answer. Number 43, which device uses the principle of electromagnetic induction? Electromagnetic induction is the induction of current due to movement through a magnetic field. So in which one of these devices do we move something between the poles of two magnets? Well, that would be in our generator. We have our crank and we move it. So remember, DC motor turns electrical energy into kinetic energy. So when we turn on the current, then the coil moves because the forces are induced on the coil. The opposite happens in a generator. In a generator, there is no battery, okay? But because we have a conductor moving in a magnetic field and cutting those field lines, then we get a current in that conductor and it can power something that's connected to it. So generator, C for 43. Number 44. The diagram shows a beam of cathode rays being deflected by two plates. Which row shows the charges on the plates? Remember, cathode rays are electrons. Electrons have a negative charge. So they are going to be attracted to a plate that has the opposite charge. So plate 1 must be positive if the electrons are attracted to it, because they will repel similarly charged objects. So plate 2 is negative. The electrons are going away from plate 2 and toward plate 1. Okay, so plate 1 is positive, plate 2 is negative. The answer is A. Number 45. The chart gives the variation of activity with time of a radioactive isotope, that should say. What is the half-life of the isotope? Remember, half-life is the time taken to decrease activity by exactly half. Okay. Now there's a little disparity in this question. So if we look at the first two values, 128, if we divide that by 2 to get exactly half the original activity, we're going to end up at 64, and the time elapsed between those two readings would be 10 minutes. And we go again, 64 divided by 2 gives us 32. 10 to 20, that's another 10 minutes. So 10 minutes would be the half-life. The other two, these don't. I think that would be an error. They should say 30 and 40 for us to continue that pattern. So that's an error. We're going to go with the first two. So the answer is going to be B, 10 minutes. Number 46. An isotope of uranium can be represented by 235. Oh, what am I saying? An isotope of uranium can be represented by the symbol shown. 235 is our mass number, 92 is our atomic number. Which row lists the number of electrons, protons, and neutrons from a neutral atom of the uranium isotope? So remember, the mass number, that's the biggest one, is the number of protons plus neutrons. Okay? And the atomic number is the number of protons only. If an atom is neutral, that means that it has the same amount of positive charges as negative charges. So it has the same amount of electrons as protons. So the electron number and the proton number is going to be the same. Okay, so just looking at that alone, we can see that C is going to be our answer, but let's work it out. Okay, so 235 take away 92 is going to give us, yep, 143 neutrons. Okay, atomic number 92, so proton number is 92. It's neutral, so electron number is also 92. So our answer is C. Number 47. The nuclide polonium, that is, decays to lead. How does this occur? Well, if we look at the differences in the mass number and the atomic number, we can tell which type of decay occurred. So from the mass number, we see that it decreased by 4. 216 minus 212 is a decrease of 4. So we lost a total of 4 nucleons. So minus 4 nucleons. Oh, wait. There we go. And the atomic number decreased by 2. So we lost 2 protons. Okay, that's characteristic of alpha decay. Okay, remember, an alpha particle has the same composition as a helium nucleus, 2 protons, and if we lost a total of 4 nucleons, then the other 2 particles are neutrons. Okay, because that's what our mass number tells us, our number of protons plus neutrons. So our answer is going to be A, emission of an alpha particle. Number 48, still talking about radioactivity. So we're talking about penetrating abilities here. When a sheet of paper is placed between a radioactive source and a detector, the count rate remains the same. The paper is replaced with a 3 millimeter thick sheet of aluminum and the count rate falls to the background level. So which type of radiation is the radioactive source emitting? All right, so the type of radioactive particles that are blocked by paper are alpha particles. And we're told that when there's paper in there, okay, the count rate remains the same. So that means whatever is coming from the source is unaffected by the paper. That would not happen if there were alpha particles coming from there. The alpha particles would be blocked by the paper and then it would not reach the detector. So the count rate from the detector would be lower. So that means that it has to be beta particles, because beta particles are blocked by aluminum and the count rate falls when the aluminum paper was put between the source and the detector. So we have beta particles coming from this source, okay? And we know it's not gamma as well, because the count rate would have remained the same, just like with the paper, because gamma rays are unaffected by the aluminum. They can go straight through. All right, coming down to the last two questions. Number 49. When the light-dependent resistor in the circuit is exposed to increased light intensity, the ammeter records a higher reading. What is the reason for this? Well, remember that light-dependent resistors, we have an increase in current when light falls on it, okay? So the light energy increases the flow of electrons in the circuit, and the ammeter records a higher current as a result. So our answer is going to be B. Finally, last question. In which circuit will only lamp 1 be lit? Okay, so lamp 1 is on, but lamp 2 is not. Which one of these circuits is arranged for you to observe that? Well, we notice that we have diodes in these circuits. And in order for current to get to lamp 1 or 2, if there's a diode in its path, it has to be in the same direction as the current. So remember, current is going to flow from positive. We take direction of current from positive to negative. Okay. So that means it's going to go in this direction and around. Okay. So this one, the way the triangle is pointing on the diode, that tells you which way it's orientated. And in this one, it is not pointing in the same direction as the current, so that one is out. It's going to block the current from getting to lamp 1, so lamp 1 will not be lit in A. In B, we have lamp 1 going to be lit because the current direction is the same, but also lamp 2 will be lit. And we want the circuit where only lamp 1 is lit. So both are lit in B. In C, we have similar situation as A. Lamp 1 is going to be blocked because the diode is reverse bias, means it's in the direction opposite to conventional current. And so our answer here is going to be D. D, there's nothing impeding the flow of current to lamp 1, but there is a diode that's going to block it to lamp 2, and so only lamp 1 will be lit in D. All right, and that is the end of the paper. Study hard, review. Good luck.